So I messed up. Like, seriously, I messed up. I was so focused on creating a workflow that could run on an absolute potato of a machine that I didn't realize I was using loads of packages, each with just one node that I needed. It was overkill. You had to install dozens of extra nodes on top of the ones you already had just to make the workflow work. But there's good news. I think I've sorted it out, at least to some extent. It's still not perfect. There are a few things that need sorting out, but it's a lot more streamlined now than it was before. And a massive thank you to everyone who left feedback in the comments. Honestly, I wouldn't have noticed half of the issues with the workflow without your input, so keep that feedback coming. Moving forward, I'm going to divide each video into 2 sections. The first part will be all about the main topic for that episode, like today, where we're focusing on inpainting and outpainting for low VRAM machines. The second part will be about how to implement the new workflow we discuss, integrating it into the low VRAM workflow. This way, whether you're just here for the new workflow or if you're building on the low VRAM workflow you already have, there's something for everyone. With that, let's dive into inpainting and outpainting using Flux Dev. The workflow we're using today is divided into 3 parts. I've very creatively called it the image manipulation workflow. Honestly, I'm terrible at naming things, but it does what it says on the tin. These 3 parts are the object removal group, the inpainting group, and the outpainting group. Before we go any further, if you don't have ComfyUI installed, I've got a video up here you can watch to help you get set up. My advice? Use the portable installation. It just saves you a lot of hassle because everything is contained in one folder, so you'll run into fewer conflicts. I also have a second portable Comfy on my computer. I use this to test any new workflow or node I download. Once you've got that sorted, download the workflow from the link in the description and drag it into Comfy. You will also find all the links to the necessary models below. Download them and place them in the appropriate places. Now, if you're planning to only use the image manipulation workflow, then you only need to download the checkpoints, clip models, VAE, and Loras. The NF4 and FP8 and 16 models should be downloaded and placed in the models checkpoint folder. The quantized models should be placed in the models unet folder. Clip models in the models clips folder. Loras in the Lora folder. The SDXL model in the models checkpoint folder. The SDXL Controlnet Union model in the model Controlnet folder, and the VAE models in the models VAE folder. That's basically it for the first workflow. However, if you plan on using the complete low VRAM workflow in the second part of the video, you'll need to download and place the rest of the models in their respective places. The first is the Flux Controlnet models in the models Controlnet folder. If you plan on using the auto prompt generator, then the large language models should be placed in the models lava checkpoints folder. The rest of the models auto download on first use. You'll notice some parts are highlighted in bright red. That's nothing to worry about. It just means that some of the nodes are missing. What you'll need to do is click on the manager button, then go to install missing nodes. A list will pop up with the missing nodes, so just select the ones you need and hit install. Simple as that. The only node that is not in the manager is the NF4 loader. To get that, copy the link in the description below, open the manager, click on install via git URL, paste it in the pop-up window, and then click on OK and then wait till it's done installing. We need to get on the same page here. When you're installing new nodes, if it's just 3 or 4 missing nodes, then sure, go ahead and click install. But, and this is really important, if you see a long list of packages in the missing nodes section, don't just install them all at once. These packages contain groups of nodes bundled together, so it's not just one node per package. What you want to do instead is install them in smaller batches, like 3 or 4 at a time. Trust me, this will save you a lot of trouble down the line. And just to be clear, some of these packages will also need to download extra stuff from the internet. A good example is the WAS nodes, which has 217 nodes, or the VLM node package, which has 28 nodes. Even though they're small, they still need to install Llama CPP, which allows you to use large language models without using Ollama. Don't just select everything and hit install. It might feel a bit slow because you'll have to wait for things to install and restart, but honestly, a few minutes now could save you hours of headaches and troubleshooting later. Let's carry on. The workflow we're working with today has 3 main groups plus a checkpoint loader group. The checkpoint loader lets you switch between 3 checkpoint types: quantized NF4 and FP8 or 16 models. Just remember, when you're using the switch, 1 is for GGUF, 2 is for NF4, and 3 is for FP8 or FP16. Now, I'll start with the inpainting part of the workflow. This bit includes 2 inpainting groups. One is the SAM2 inpainting group, which I use for automatic object selection in images. The other is a manual inpainting group, which lets you control things yourself. In the manual inpainting group, we start with the load and resize image node. This is where we load our image into the workflow. We'll talk about the resizing part of this node a bit later. After that, we've got the Gaussian blur mask and grow mask nodes. It expands the borders of your mask and adds a blur to soften up the edges. It's brilliant when your mask isn't perfectly precise. To be honest, I always use them, no matter how good my mask is. Next up is the mask to image node. What this does is show you the image of your mask, so you can see exactly what area is being affected. Below that is the image composite node. This is super useful because it composites the mask over your original image, letting you see the mask on the image itself. Moving along, in the next row, we've got the appositive clip text encoder and the conditioning zero out node. That last one, the conditioning zero out node, is key. It essentially zeroes out the pooled output, so it's perfect for a Flux negative prompt because it turns all input to 0. Next to that, we've got the Inpaint model conditioning node. This node takes all of the inputs and ports them to the sampler. The sampler, by the way, is just a group of nodes bundled together for convenience. Above the sampler is the differential diffusion node. This node allows for changes on a per pixel basis rather than affecting the entire region, which gives you a lot more precision when editing. In other words, instead of just masking out a specific area to make changes when in painting, differential diffusion lets you apply the mask as a gradient instead, giving you much smoother transitions. And lastly, we've got the VAE decode and the preview with the image compare node, which you'll find from right tree just below. Okay, now let's quickly look at the SAM2 section of inpainting before we run through an example. For this, I'll be using the Florence 2 nodes along with the SAM2 group of nodes. First up is the Florence group. You'll start with the download and load Florence node, which then connects to the Florence 2 node. This is where you select the large language model you want to use for segmentation. I usually switch between the Florence 2 base or large models. Just keep in mind that these models will automatically download when you run this group for the first time, so you don't need to do anything extra there. Just below that is the Florence 2 run node. We'll look at it in more detail when we put it into action in a bit. Next to that is the preview image node, which shows you exactly what's being selected. The next row contains the segment anything 2 nodes or SAM2. This is the successor to Meta's segment anything model, and it provides object segmentation for both images and videos. The first node here is the download SAM2 model node from segment anything 2. I'm using the SAM2 small model here, and like before, the model will automatically download the first time you run it. Below that, we have the Florence 2 coordinates and SAM2 segmentation nodes. These work together to fine-tune the segmentation. The next row contains the grow mask node and the Gaussian blur mask node, which extend the edges of the mask and blur them a bit to make sure they blend well. Then we have the 2 preview nodes. One shows a preview of the mask on the image, and the other shows the mask by itself, so you can see how well it's been applied. Let's actually test out the manual inpainting. First, we're going to deactivate the SAM2 inpainting group and enable the manual inpainting group instead. You'll want to click the little arrow next to inpainting manual to get to that group. I've set up a switch here so you can choose between the mask coming from the manual or auto inpainting groups. Just to keep it simple, 1 is for auto inpainting, 2 is for manual inpainting. For this demo, I'm going to select 2 for manual inpainting. Click on Choose File, upload the image you want to inpaint. I'll use one I created earlier. It's an image of a man in pink shorts. Once the image is uploaded, you've got two ways to add a mask to it. The first method is by right-clicking on the image and selecting Open in Mask Editor. The second option is to right-click on the image again and choose Open SAM Detector. For now, I'll use the first method, Open in Mask Editor. The mask editor itself has a few settings you'll want to adjust. Thickness, which is basically your brush size. Opacity, how solid or transparent your mask is. Pointer type and color. To adjust the brush size, you can also just scroll up or down with the middle mouse button. You can choose between 3 different colors, black, white, or negative. Any of these will work just fine. As for the opacity, you want to keep it low enough that you can just see through the mask a little. For this example, I want him to have trousers, so I'm going to mask in some pants and then save that to the node. There are a few settings you can tweak in the Load Resize Image node. You can adjust the custom width and height of your image. What I've done here is added the Flux Resolution Calculator, and I've kept the megapixels set to 1. If you've seen the previous video, you'll remember I mentioned 0.5 megapixels for low VRAM, 1 megapixel for SDXL resolutions, and 2 megapixels if your hardware can handle large image generation with Flux. Here's why I've included this in the workflow: inpainting large images. Sometimes you've already upscaled an image, like I had one that was 4096 by 4096 pixels, and I couldn't figure out why it was taking forever to process. Turns out it was just too large to manage efficiently. What I did to fix that was use the resolution calculator in the workflow and adjust the image's megapixel size to 1. With an aspect ratio of 1:1, a perfect square, that brought the image down to 1024 by 1024, which is much more manageable, especially if you're working with 8 GB of VRAM like I am. If you decide to go this route, there are a couple more settings you'll need to tweak. First, you'll want to set resize and keep proportion to true. But since the image I'm using is small enough for the sampler to handle, I'm going to turn resize and keep proportion off. Doing this disables the Flux Resolution Calculator, so we'll just be working with the image as it is. I'll leave the blur mask at its default settings, the grow mask to 3, and move on to the prompt. Let's go with a man in matte green cargo trousers. The sampler works a little differently here. Notice that I'm not using 8 steps. I've got some bad news for all you speed lovers out there. Inpainting doesn't really play well with the Hyperflux Lora. I tried it for days and couldn't get any results. So instead, we're going to keep the steps at 20 for the Depth model, or 4 if you're using the Shnell model. And make sure the denoise strength is set to 1. You'll also want to turn off the Hyper Lora here. And just like that, from shorts to trousers, if you want to keep editing the image, just right-click on the inpainted image, select Copy Clip Space, then right-click on Load Image and click Paste Clip Space. I want to add a shirt, so I'll open the image in the mask editor again. And this time, I'll highlight the torso in the shape of a shirt. Then I'll save that to the node. For the prompt, let's go with a man in a white long sleeve shirt. Hit Q and there we go, fully dressed. Like I mentioned earlier, I couldn't get the Hyperflux Lora to work here, but let me know in the comments if you've had any luck with it. Next, let's jump into SAM to inpainting. This is honestly the fastest way to mask an image. All you need to do is describe the object or part of the image you want masked, and it will automatically handle it for you. You're essentially prompting the software to create a mask for you. But before we start, let's run through a few settings. First off, select the Microsoft Florence 2 base model. This is what we'll be using for the masking. In the Florence 2 run node, I'm going to add hair as an example. For the task, I've selected caption to phrase grounding, and I've pretty much left everything else at its default settings. Next up is the Load SAM2 model node, and here we're using the SAM2 small model. The grow mask setting is expanded to 3, and the Gaussian blur mask is set to 10 for both the kernel size and sigma. Right? Let's load an image of a woman in a blue evening dress. For the prompt, I'm going to change her outfit to a beautiful white evening dress with intricate golden patterns. I'll write dress in the Florence 2 run node. Make sure you change the switch mask to 1 for the SAM2 group and then click on Q. What happens here is pretty cool. It automatically detects the dress in the image, masks it, and then inpaints the new dress based on the prompt. Not quite white, but still, look at that. It's completely transformed the dress. If you're happy with the result, you can copy the generated image like we did earlier, place it back in the load image node, mask whatever you want to change next, and then just repeat the process. It's really that simple. Just a quick heads up, you might not always get the perfect result on the first try. If something looks off or isn't quite what you were expecting, just run it again until you get something you're happy with. In my experience, it's a bit hit or miss. Sometimes it works brilliantly, and other times it'll give you the strangest results. Give it a go and see how it works for you. Next, let's have a look at the outpainting part of this workflow. There are two groups we'll be working with here: outpainting image load and outpainting with SDXL. In the first group, you've got the basics. We start with a regular load image, followed by a flux resolution calculator. This helps resize the output image to the size you want. Next, you'll see an image blank node. This adds a blank background to your outpainting. After that, we've got the Layer Utility Image Blend Advanced V2 node. This one's important because it creates background and foreground layers, and it helps you position your image exactly how you want it. For this example, let's use a close-up portrait of a woman because we're going to outpaint with SDXL later on. I'll set the megapixels to 1 and the aspect ratio to cinema view. This keeps it manageable. Before we go ahead, let's make sure all the other groups are deactivated and only the outpainting image load is activated. Once that's done, click Q so we can see how the image is positioned. You'll notice that you can use the X% and Y% values to move the image around. I want this image to be dead center, so I'm going to set both X% and Y% to 50, and that'll move the image right to the middle. Here's how this works. The X value moves the image left to right, side to side, while the Y value moves it up and down. We'll go ahead and activate the outpainting with SDXL. Click on the arrow to head into that section. For this, I'm using the Real Viz V5 Lightning model. The reason I like this model is that it produces really high quality images with just 5 steps. I've tested other Lightning models. Some were fantastic, while others not so much. If you're going to try a different Lightning model, make sure it's a newer one. One thing to keep in mind here is that this is an SDXL model, so all the regular settings apply. For instance, I've got the clip set last layer set to 1 as recommended on the model's download page. Basically, you can tweak it however you need to, based on what works best for your SDXL workflow. I've also added the differential diffusion node, and for the Controlnet, I'm using the SDXL Union model. Just make sure it's the Pro Max version of the model. You also want to check that the Union Controlnet type is set to repaint. For Apply Controlnet, I've got the strength set to 1, the N% at 1, 5 steps for the process, and the CFG at 2. I've selected DPM++ SDE for the sampler, Keras as the scheduler, and the denoise is set to 1. In the Flux section of this group, I keep the CFG at 3.5. The Grow Mask, Expand, and Blur Radius at 50. You can choose whether you want the seed set to fixed or random, and you can adjust the max and base shift to whatever feels right for you. The scheduler is set to SGM Uniform, denoise at 0.3, and the steps at 8. Make sure to turn on the Hyperflux Lora. Let's add something simple like a woman in a room for the prompt. Once you're all set with these settings, press Q. You can increase the denoise a little bit if you want Flux to make more changes to the image. Honestly, it looks fantastic. Let's quickly recap the outpainting process. First, activate only the first part and adjust your image as needed. Then, activate the second part without deactivating the first part. Adjust the settings I mentioned earlier and then run it. Just a quick note, the Hyperflux Lora only worked with the outpainting for me, not with inpainting. You'll want to add it to your Lora stack when outpainting, but remove it for inpainting. Let's take a look at the other two groups, the object remover and the background remover. These are pretty straightforward. For the object remover, you load an image, mask the part you want to remove, and it'll take care of it. Like a lot of things in AI, it's sometimes a bit hit or miss, so keep that in mind. The model for the Big Llama remover downloads automatically the first time you run it. It's the same for the background remover. Load an image, press Q, and it'll remove the background. Again, the model will download automatically on the first run. Just a heads up, if your internet's a bit on the slow side, patience will be key here. It might take a little while. You can download the image manipulation workflow. I've linked it in the description below. And just to note, you can totally use this on a low VRAM system, so no worries if you're working with limited resources. Let's look at the low VRAM workflow and how I've implemented image manipulation into the existing setup. But first, there's now only 3 custom nodes that's not in the manager. First is the Mile High Styler, second, the Mistoline Node, and third, the NF4 loader. The easiest way to install them is by copying the link in the description below and then opening the manager. Click on Install via Git and paste it in the pop-up window. Click on OK and then wait. Let's talk about what's changed. The first thing I updated is the number and types of models you can choose from. You've got options to choose between GGUF, NF4, and FP8 or 16 models. In the previous workflow, the checkpoint loader wasn't working correctly because it was trying to find checkpoints in the wrong folder, the UNet folder to be precise. That's been fixed. Also, the switch isn't just a simple true or false anymore. You've got the option to choose between 3 different types of Flux models. 1 equals quantized, 2 equals NF4, and 3 equals FP8 or 16. Another thing I've done is reduce the number of nodes used in the workflow. I found alternatives for some of the packages, so now I'm using just 1 node where I used to have a lot more. This actually let me remove about 18 packages with hundreds of nodes, which is a huge improvement. Next, let's look at the string function prompt in the auto prompt generator. The previous workflow used 2 nodes to inject text before and after the large language prompt. The new node only uses 1 node for that. All you have to do is add the before text in the text A field and the after text in the text C field. Let's test it out. First, let me make sure the other groups are disabled. And now I'm going to add a giant dragon in the middle of a city in the subject field. I'll keep the prompt type as normal and the style as realistic. In the text A field, I'll add realistic. Photoreal 8K, this will come before the generated prompt. Then, in the text C field, I'll add cinematic, which comes after the prompt. Let's hit Q and see what happens. Oh, and if you're having trouble with this group, it might be because Llama CPP is missing, so make sure that's installed. Next up, we've got the image to prompt group. This one's pretty much the same as before. It still uses the Florence 2-run model to generate a prompt from the image, using the Florence 2 SD3 captioner model. Right next to that, we have the text to image group, and that's the same too. Now onto the Flux Controlnet Upscale. I'm still working through some issues with image sizing here, but you can check out my previous video if you want more details on how Controlnet upscaling works. The link to that video is in the description below. The Flux Controlnet itself hasn't changed, and again, you can get more info on that in the earlier video. The Mistoline group is still the same as well. Everything you need to know about it is explained in the video linked in the description below. You don't actually need all the models for the workflow to work. For instance, if you only have the NF4 model, that's all you'll need. And if you're only using the quantized model, that's the only model you'll need. Like I mentioned earlier, it's an index switch, so only the nodes that are indexed will be loaded. The newest addition to the workflow is the image manipulation section. This is where you can edit your images, removing backgrounds, taking out objects, and using inpainting and outpainting. I've added group bypassers all over the workflow, and they're color-coded, so they match the group they represent, which should make things easier. Alright, that's everything for now. Thanks so much for watching this video. Don't forget to like and subscribe if you found this helpful, and if you've got any questions, just drop them in the comments below. I'm always happy to help. See you next time.